In this video I'm going to talk about the long-run production concept of returns to scale. Your book has a nice graph that illustrates this concept. Here we have a number of different isoquants. Here's an isoquant showing all combinations of labor and capital that can produce 1 unit of output. Here's another isoquant showing all combinations of labor and capital that can produce 3 units of output, and so on. We have 4 of them, in fact. So increasing returns to scale would be defined as a situation where if the firm were to double all of its inputs, output would more than double. So for example, when this firm goes from the input mix of 1 unit of capital and 1 unit of labor here at point A, and if it then doubled all its inputs, it would move to point B and output would be 3. This is a more than doubling of output from doubling of the inputs. So again, increasing returns to scale is a situation where if the firm were to double all of its inputs, its output would more than double. So going from A to B, as noted here, is an example of increasing returns to scale. There's this other concept called constant returns to scale. Here as we move from B to C, once again we double all our inputs, going from 2 units of capital to 4 units of capital, 2 units of labor to 4 units of labor. Here a doubling of all the inputs exactly doubles the firm's output. We go from producing 3 units of output on this isoquant to 6 units of output on this isoquant. So constant returns to scale, a doubling of inputs exactly doubles the firm's output. And then the final concept is decreasing returns to scale. At point C, if we were to double all of our inputs, going from a combination of 4-4 to 8-8, notice that the firm's output goes up less than double. It doesn't go up to 12, it doesn't go up to 14, it goes up less than double, only to 8 units of output. That would be decreasing returns to scale. Okay, some examples as to what might cause increasing returns to scale would be the following. Increasing returns to scale may come about from larger plants that are able to take advantage of specialized equipment that cannot fit into smaller sized plants. So as the firm gets bigger and bigger, there may be some gains here from robotics and other specialized equipment. Also, as the firm gets bigger and bigger, increasing returns to scale can result from greater specialization. Assembly line techniques, for example, are easier to accomplish in larger facilities than smaller facilities. So those are some of the common reasons given for increasing returns to scale. Decreasing returns to scale may come about because some inputs simply cannot be doubled. We talk about doubling labor here, going from 4 to 8, but we're not talking about specific types of labor. Labor is heterogeneous, so managers, talented workers, special work teams, and so on, some of these things cannot simply be duplicated. Therefore, decreasing returns to scale may result. All right, now let me look at the technical aspect of returns to scale and how to determine whether a production function has increasing, decreasing, or constant returns to scale. Let's start with this production function here. This is going to be of perfect substitutes. Okay, so the easiest way to determine if a production function has increasing, decreasing, or constant returns to scale is to do the following. Start with an input combination. The easiest one is 1 and 1. So I'm going to plug 1 and 1 into this production function, and we're going to get 17 units of output. What would happen if we doubled all our inputs? Capital goes to 2, labor goes to 2. Plugging these values now into the production function, just write it here, we're going to get 34 units of output. So as we double all the firm's inputs, output exactly doubles. This is constant returns to scale. Let's do another example. We'll put 1 and 1 into this production function, We're going to solve that. We're going to get 3 units of output. Plugging 2 and 2 into this production function, we're going to get 8 units of output. 2 plus 2 times 2 is 4 plus 2, that would give us 8. So here we got increasing returns to scale. By doubling all the firm's inputs, output more than doubles. Let's do another example. Let's say we have a production function that looks like this. L to the 1/2 power k to the 1/4. Plugging 1 and 1 into this production function, we get 1 unit of output. Doubling all our inputs, we get 1.68 units of output. So a doubling of inputs did not quite double our output. This is decreasing returns to scale. Okay, let me do a few more. The quantity of output equals L times K. One and 1 gets us 1 unit of output. 2 and 2 gets us 4 units of output, increasing returns to scale. And finally, one more. The quantity of output Q equals the square root of L times the square root of K, capital. 1 and 1 gets us 1 unit of output. 2 and 2 gets us 2 units of output. Constant returns to scale. Oops, CRS. So that's it for returns to scale.